I prefer PAO.
So let's start when sister now recording. So the aim for this practical is to cover the concept of generic programming, which is achieved using templates in C++. We write a simple board game. The game starts off with a board of values, which could be the characters or integers. Depending on the type defined by during construction, a seed function is used to randomize the values within the board. So we're just achieving basically they're introducing you to templates here. Or overload and not hey, yeah, the overloading and overloading one way. I So let me explain how to do overloading. So the reason why we do overloading is so that we want to create a class that can use an array of any data type. So even a function, you can create something that can take any data type. So we're gonna start with function templates, right? So templates and then view and then manager. And then there we go. So we're going to start with function templates. So the way you make it a template, right? You define the function the way you normally do, right? So let's say, for example, I want to define a function that prints, right? So I'm going to say void print, or just print, right? So void print, and then it takes in, this, say, for example, takes in a string, right? str text, which is some text, right? This basic thing, right? And then I'm going to say see out that text. So str text, and then put in end of line character. So if you look at this function, right, it takes in only a string. That's the data type that it takes in. So if you try to print something else other than a string, then you would have issues. So I can say print hello world, and then at the bottom, and then I say print how are you? So I can call this method as many times as I would like to call it, but then the parameter is the important part here. You can only pass the parameter that you've defined. So you see it says hello world and how are you, which is exactly what I told it to print. Remember, the computer just takes instructions. It's like a pet. You tell it sit, it sits. You tell it print world, it prints. Its main goal is just to follow your instructions. So as you can see, this print function can only take, we told C++ that it takes in a string. What if we try to go against this law and say, I want to print a 3? So what happens is when it looks at this line of code, it's going to go over the function over here, and then it's going to look at this variable, or that's the variable. So this is basically what happens behind the scenes. Let me explain to you what happens behind the scenes with the function. So let's say line 1 here, line 12 here. I passed in a string. So it's going, and I call this method, and then I passed in a parameter, which is a string. So what happens is that it goes to where this function print is defined or declared, which is here. And then that parameter, it gives you that value, it sets it to that value that you've passed. So it comes in, it does this. It says is equals to hello world. That's why it prints hello world when it's called with hello world, because when you pass that parameter, we're telling it to initialize that parameter to that text that we've passed when we called the method. But then if you call it again in this next line, you pass that text, now this 3 str text will be initialized to a different text. Hence, it prints the different text, right, or the different strings. That's what's happening behind the scenes. So what happens now when you try this here? You're passing 3, so that means it's going to try and say it's equals to 3. Do you see the problem now? It's string, but then I have a number here. So they're incompatible. Because remember, the variables, it's a box that can only take in that type of data or that type of information, which is text. Then now we are violating those rules that we've told the computer to abide by. Now we're telling it, okay, in that box, try to put a number. It'll be like, what do you mean put a number? You told me it's a string. Why are you being self-contradicting? Because you said you want a box that can store strings, and the box should be named or should be labeled str text. Now you're trying to store an integer. Well, now it starts beefing with you. Okay, let me do this. Okay, so I'm also gonna just explain functions while we're at it because we're supposed to have a session where we explain functions. So you see three, he says it failed to convert three from three from an int to a string. Because this function takes in a string, it failed to convert that int to a string. So if you wanted it to pass a string like that, you'd have to convert it to a string. There's a way you can convert. You use static underscore cast, and then you put this brackets here like this, and then you pass the data type you want to convert it to. So I want to convert it to a string, right? And then that's the value. So you'll notice something similar when you do templates. This static cast, right? It's actually we can view it as like a function that takes any type, right? So the type must pass within this greater than and less than sign. So you see now I've casted the value to a string. It should work, but then it's actually giving me problems, but it should work. So that's why it's complaining because it's gonna try and come here and then initialize to a 3, but then 3 is a number, not a string. So how can we make this function flexible to take in any type? We can make it a template function. So we can make it a generic function. The keyword is generic. Generic meaning that it doesn't actually do or do it one specific thing. It's very generic. It's like a template. Hence, we use templates. It's like it's something that you can manipulate on your own. You basically get like at the starting point, then you can manipulate it in whatever way you want to manipulate it. So you say type class template type like this, and then you say class, and then you can give it any name here. You can call it T, you can call it type, you can call it whatever you want to call it. So I'll call it T, right? So so basically what I'm trying to say is that I'm telling C++, listen here, I have this method here. Remember, we're not done fixing the method. I'm just explaining the template part. Listen here, I have this function and it should be a template, right? It should be a function template, meaning that this function can take in any type. So for now, just think of that type. Just think of the type as a type called T, right? It's just some type called T. So you can use one of two ways to define that generic type, right? You can use class, or you can say type name. We typically use type name, or type name is more advisable because why? For example, if you have a class called UJ image, so you have a class UJ image, right? There it is. And then you make it a template class, and then you say class T. You see that it kind of gets confusing. You're seeing class here, you're seeing class here. So that's why they advise you to just use the second technique, which is type name. So since we've defined a type name, right, we need to change the type that this function takes. You should take in some type called T. You remember you can name it whatever. I've called it T. And you can call it type, but then you must use that type, that name that you've defined. If I call it type, I call it type also here. So what this means, it means that it's any type. So let me just do this. Let me name it like this. It's any type. So the any data type can go there, meaning that this function can print literally anything. And then we just output it to the console. So let's try to print, right? So you see that now this line of code over here should stop complaining. Let me build, yeah. So you see, So you see the error is gone. That's the
Yeah.
benefits of, and you see it's 0. It's blue. It's perfect. So that means there's nothing wrong I did. They didn't do anything wrong. So it takes in any type, and then you can build and run, and you see that it's gonna print the number. You see? It prints
Yeah.
3. It prints 3, and then it prints hello world, it prints, and you can also print a character. You can say print like this. You can basically can print anything. A, because it can take in any type. I didn't limit it to only taking like chars or whatever. And then you can also take in a float. So 3.14, right? You see that it's printing all these different data types, which is very powerful. You see, all of them. So this function can take in any type. And you can do the same with the function with the class. Let me see something here. I want to check something. I think you can also do this. Um, uh, I want to check something. I just want to double check my syntax. Yeah. So there's two ways of calling it, right? Yeah, it does compile. So there's two ways of calling it. Remember, this function, it takes it any type. You can just pass the type, the information you want to display, and then it's gonna interpret what type it should be. So this is how it works behind the scenes. It's going to see, okay, it's going to check what data type has been passed. Oh, it's a string. Then it's gonna come here and change this to a string like this. So that means this now becomes string, and then it prints the string. You pass in an integer, it checks the type. Oh, that's an int, so int, and then comes in, makes it an int. So it's flexible in that way. That means it can take in any type. So I'm gonna put it back to any type. So you can also be explicit and say this function is going to print integers. So if you look at it, we've used the syntax here, and it always goes after the name of that thing, whether it's a function or the class. So you see, there's the template, right? Doesn't it look familiar? You see?
That. Yeah.
Yeah. So that's you. I know here it was defined before the function, but when you actually define the type, when you invoke the function, you put these brackets in front of them. Remember, when you use the keyword template, you don't have to type don't do spiritual syntax like this. When it's like this, just like here at the top, I'm still defining it. I don't need to use the keyword template. It's already defined. So I just leave it like that. And then use the same symbols that I used when I was defining the type, which is this. So you see here I've passed, okay, so this is actually how it works. So here I've passed the type to int, and then it's gonna come here and then it's gonna be an integer. So that means it's gonna change this to an integer, just like I explained previously. So it's flexible. That's how it works. That's pretty much what templates are for. So I'm going to do that. And then there's many ways you can call it. You can just call it normally like this, and then it will auto-fill what string what type it should be. Is it a string, a char, or a boolean, or a float? It will automatically fill it in. Like when I say anything, but I can print anything. Like you see, I'm printing now a boolean. I'm printing true, which will be a 1, because remember in our last sessions, booleans automatically they display integers on the console.
Yeah.
You'd have to change the setting so that it outputs true or false. So you see, it's printing any type, and there's no error here. It's not complaining because it knows that the syntax is valid. So since this is valid, it's not going to complain. So this will be a function template. This is
Yeah.
an example. And okay, let me call this another way of invoking the function template. That's pretty much all you have to know, man. If you understand the syntax, that's pretty much all you have to know. So now let's get to how would you define a class, right? So let me make specific files like a header file and a CPP file. Why am I doing that? Because if I don't do that, then you won't understand the flow, right? I might write it in one file and then it's gonna work on my side, but then when you guys do it, it doesn't work, which is a problem. So I'm going to create a PP image. Let me see. What should I create it? I'll create an array class, right? Dot H, which basically represents an array. Well, let me see. Should I call it 2D array? Now let me make it a one-dimensional array to save time. So I'm gonna make it a one-dimensional array, click all, and then finish. And then I'm going to say new, and then file. And then I shouldn't, since remember I want to make use of templates, I shouldn't use C++ source file because I'm creating something that can take in any type. So this
Yeah.
type that I'm defining is just basically I'm defining my own type, which is any type. And C++
Yeah.
doesn't know something called any type. There's no such thing as any type in C++. Hence, you shouldn't create a .cpp because it's going to crash. It will say, I don't know what you're talking about, but there's no such data type inside C++. What do you mean type
Mm.
or T? What do you mean? So I shouldn't create a .cpp. I'm gonna create a file and put my own extension to represent. That's why when you do templates, it doesn't do auto completion. When you start typing, it doesn't auto complete. You'll see. So do you see I'm inside a header file? It knows that a header files contain C++ code. So that's why therefore it shows me suggestions to autocomplete. So template, and then remember we said we should use type name. So the class you're gonna declare it as usual. So this is my array class, and then my array class, just so that I don't have too many things, right? I'm just gonna create a few things, but I'm gonna need a constructor, obviously. Array, and then I'm gonna need a constructor that takes in the size. So I know that size is gonna be unsigned, so an unsigned short, right? And then destructor, and then private, and then let's create the array. Remember with the array class, right? Or with that class, you usually have the array as a specific type, right? You have, for example, int pointer, something like this, and then underscore values. It was of a specific type. It was an array of integers. Now I've defined my own type and I've called it T. I need to make sure this array is of type T, meaning that it takes in any type, right? And then what I'm going to do is I'm going to create, to show you that this thing works, right? I'm going to create, let me think. Should I create a 2 ppm? Nope, let me not create a 2 ppm. Let me create a function that gets the value, right? So an accessor. So usually, remember, you get an int and call it right get value because it was an array of integers, meaning that at every single index there was an integer. And then you put a const there at the end so that the code that you're gonna write, this function's implementation does not provide code that will what is this? Does not provide code that will, what's that keyword? That will mutate or change the state of our class. Hence, it's called an accessor because it's only meant to access. But then remember, we need to take in an index. So unsigned short. We need to take in an index to index into the array. You can just pass an integer. It doesn't really matter. I like to be accurate. I'll use unsigned. And because I have a deep understanding of data types, I will use unsigned short. So usually it returns an int because our array was an array of integers. What type is our array? It's array of type T. I've called it T. So I should return a T here, like this. And
Oh.
then that's pretty much all I have to do. I'm just going to create an accessor. That's it. And then I'm going to go to my, okay, this, there's something that's really annoying. You're not gonna like it, but it's something really annoying. Remember, when you put template here, what does it mean? It means this is what it means. If you remember vectors, like you do vector to declare a vector, you put brackets like this and then pass the type here, whether it's
Yes.
an int or whatever. So this vector class actually makes use of a template. So that means the same way we use a vector, since this class is similar to a vector class, that means every time I use this class, I need to put those greater than sign like this. Even if I'm doing, even if I'm implementing, like let's say for example, I'm saying I'm using this scope resolution, and then I implement my construct. I need to also pass it like this. Because why? The array class is templated, meaning that it can take in any type. So that's the syntax. It forces you to always, it's weird. For every line, you see, for every function or constructor, everything that's like a function or constructor, literally everything, even the destructor, you must always put this template type name T on top of it every time you are implementing something new, because the whole class is templated. So I'm going to say file. I don't want C++ file. Why? Because if you check the T type is not defined in C++. I just made it up, right? If I try to compile that, that's going to crash. It'll be like, Chief, are you sure what you're doing? So what I'm going to do is I'm going to create an empty file, and then I'm going to call it array. I usually call it .cpp, right? I'll call mine anything. I'll call mine .temp. Wonder what did Dr. Strong name it? I forgot what they how they name it. How do they name theirs? You can name it anything. Dot what?
IMP.
Oh, implementation. Yeah. Dot IMP. Yeah, now it's coming back. I remember Prof Coulter teaching us. So you notice something. Dot .imp, you've made it up. It's a made up thing. Does not exist. So you want to highlight. Oh, okay. I need to specify which folder to put this file. You don't highlight. You see? Now you'll be like, hey, what's going on? Why is my screen white? And then you type int name. You'll be like, hey, what's going on here? How come it's not highlighting? Because .imp is not recognized as the code blocks doesn't know, or C++ does not know anything that's called .imp. Even in Windows, there's no file called .imp. You've made it up. So you need to tell code blocks to assume that anything that ends with the .imp is gonna take in C++ code. How do I do that? I simply go to settings. Okay, since I have this thing on my screen, I need to do this. You need to go to settings and then editor. Editor is where you're texting here. That's called an editor. So I want to go to editor settings because I want to support that syntax highlighting. To highlight when you type and it highlights, we call that syntax highlighting. So you're gonna go to the syntax highlighting section, and then you're gonna go under file masks, right? In file masks just means what are the extension of files that should provide that codeblock should provide syntax highlighting when it sees C++ code inside of those files with those extensions. So I pass those files. These are the list of files with the extensions. So if I do use a magnifier here, you'll start to see what I'm talking about. You see, there's the .cpp, there's the .cc, where's the .h? There's the .h here, over here. There's the .h. So that means all of these files ending with these extensions, when code block sees C++ code, you should highlight it because that's C++. So if you look at this, how have they written it, right? So I'm gonna open Notepad and then so I'm gonna do this. So this is how they've written the file masks, right? I agree they're called file masks, basically meaning that file extensions. So what are those file masks? There's the .cpp, we have the .h, then we have other ones .cc. You don't need to know about those. There's different ways to name them. So if you see how everything is saved, they always put a star before it. If you remember batch files, a star means everything that ends with a .cpp. So every new file that you create that ends with .cpp, when CodeBlock sees the recognized C++ code, highlights that. That's what it means. Even here, I need to put an asterisk to say everything, because there's no way I'm always going to create one .cpp file or one .h file. So among this list of extensions, I add my own made up extension so that it provides the highlighting. So I'm going to say asterisk, right? That star to, okay, I think my screen, you can't see it very well. Let me put it here. So I'm going to say star like that, and then dot imp. If you've named it .temp, you must put .temp. That if that's how you're gonna name your implementation files with that have templates inside of them. I'm gonna call it .imp, standing for implementation. So that's all you have to do. Star .imp, meaning that every file that is created which ends with the .imp provides syntax highlighting if you recognize C++ code, which is what we want, because we don't want to have a mundane. If you look at this, where it doesn't want to remove, but you look at the way we typed it, it's mundane, right? It's white. It's a white background, which is not what we need. So I'm going to have here, I'm going to click here, OK, and then OK. You see, automatically it picked it up because I told it to pick up or highlight when it sees C++ code. So now every time I create a file that ends with a .imp, it picks it up. So now I need to call all of my methods, whether it's a constructor or whatever, put them inside this file. And then, so these are all my methods and my constructors. So I have all these methods and constructors. So on top of every single method or yeah, every single thing, whether it's an array, whether it's a what is this? Whether it's a constructor, copy constructor, parameterized constructor, no args constructor, whatever type of constructor that you have, you're going to define. Uh, let me see. Okay, so before everything, anything that I'm going to implement, right? I must always say template type name. Because why? When you use template type name, it means the whole class is generic. That means even the implementation, the things that will be implemented within the class, they make use of something that is of type template of type T, which is of any type, right? Which is this array. Remember, inside the constructors, we initialize the array, right? What type is the array? Type T. So we always need to provide this. This is a very annoying thing. I get it, but you need to put it everywhere on top of every single method. And then this is the constructor, right? So I'm going to access and say, do this, and then fine. But then something is missing here. I know this is the syntax we're used to, right? This is incorrect. Why? Because array class is a template. It's just like a vector. If you remember first semester, remember a vector initialized like this, right? So that means whenever you use the name of the class, it must be appended with these two symbols, because this class makes use of a generic type, meaning it makes use of any type. So I'm going to type, what type do I pass here? Remember, I've called it T. So I just put T there. And then I do that everywhere. Everything that I'm implementing, I put it I put it in that way. And remember, you always put it right next to the function names. And then I'm going to put it here on my destructor. And then there we go. You might be shocked and be like, well, what's going on? How come you didn't say hash include what at header file? Well, remember that .imp is not C++ code. So the way, in order to avoid divide and conquer, right? To divide and conquer, meaning we're going to have two separate files. We separate the declaration and the implementation. Hence, we call this file .imp because that's the implementation kept separate. It's called separation of concerns or divide and conquer. So it's a bit weird. Templates are a bit weird. I know. I know C++ is very intimidating, but just try to understand what you're doing step by step. You won't have any problems. So since .imp is not a recognized C++ file, I cannot say come here and say hash include that header file array.h. I can't because it can't compile a .imp because C++, if you check the documentation, there's no such file called .imp. So in order to link the declaration of your class and its implementation, you include it in vice versa now. You actually include the implementation file in the header file. I know it's a very cryptic thing, but that's how it works. So the question is, where do you include it? You obviously need to include it after declaring. Because if you include it before, let's say you come here and you say hash include, and you say array.imp. If you include it before, you're implementing something that's still not yet defined. You see the problem? It's a huge problem because remember with the hash include, what hash include does, it tells the preprocessor, which is the name of the program that does that, to go to this file, copy and paste everything that is in that file, starting from this line 4 going downwards. So this is what's going to happen. I know this session will be as longer than expected, but I want to explain everything, even though it seems basic. So it's going to paste here, and then you see, now it's going to see, okay, you said array, but a computer reads from top to bottom. It's very stupid and intelligent at the same time. That's the computer. It's going to start at the bottom, start here, okay, if not defined, blah, 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 and then it goes here, and then it comes, it's like, here, bana. What is array? What is that? What is array? I don't know it. It's stupid, I know, because it's down there. So yeah, don't include before defining the class, include it after. So you're gonna go down here and then you say hash include array dot imp. And then it's going to go to that file and copy and paste everything that's inside that file at that specific line. So we have this here, and then now you can also do constructor chaining. Everything is as you can do it as usual. So I'm just going to chain this to my constructor called arrays. So I'm going to need a constant for that. So let me define a constant. So static const int default value, right? Oh, okay, I see. Remember, the array doesn't take, before I make that mistake, the array doesn't take a specific type. We don't know. So we can't actually create a constant. We can only work with parameterized constructors. Yeah, you can only work with parameterized construct. And I made a mistake, my bad. This thing is templates are very confusing. So we are no longer, remember the array is not of type int or whatever. So, oh, okay, this is fine. It takes in the size. So we can take in the size of the array, which is this unsigned short, comma, followed by the default value, which is of type T. So remember what I said, in header files, you can just define the type. That's enough. You don't need to define anything more. And then inside the implementation, you name those parameters because you now actually want to use those parameters values. Inside the header file, I'm only declaring them. I don't need to use those parameters values. And the get value function is taking a short or an integer because it's indexing. Remember, the value at each index is actually a different type, but does it mean that I stop indexing using integers like this? No, I still use integers to index. Hence, I'm going to pass that index to index into this array and get that specific value. So I'm going to go back here. So don't put parameterless constructors because with templates, you don't know what the actual default value should be. And then here I should also take in the default value because it's any data type. It's gonna crash because if you say static const int here and you set it to an int, What if the user uses this class and when they use this class, they pass a string. So that means we can have an array of strings. That means your program is gonna crash. So then, therefore, you shouldn't create any constants here, especially for the default value. But for the default rows and columns, it's fine because for rows and columns, we always use integers to count. Have you ever counted using characters? Yeah, it doesn't work that way. Yeah, don't think about those. What are they called? That maths. Is it what is it called? Romans, what is it? There's those symbols that they use to to calculate. That's not what I mean. We use numbers. So this will be the array size, right? So I'll call it length. I'm giving them names now because I actually want to access these values that are being passed as parameters. So length, and then this will be default value. I'll call it default value because that's a default value. I need to get a bigger computer because my screen is so small. So now let me instantiate the array. As usual, there's nothing new. But then I also need to store the length. I forgot to do that. So I'm gonna use an unsigned short because I want to save space. So underscore length. Because remember, you guys, I'm making very small images, whatever. You're not solving, writing code for a Mars project or anything. Don't use big data types like int. Just use short. If you don't like unsigned, just say short. Yeah. So let me initialize my length. So underscore length is equals to length. You see, no auto completion. So you have to be very, very careful with capitalization. Remember C++.
May I please ask something?
Yeah,
May I please ask?
yeah. You can ask.
Why did you also include the T default value? And
Uh,
why is it not only unsigned short length?
because I'll show you this now. Let me finish typing the code, then I'll explain to that part.
Okay.
So let's instantiate the array, right? So it's called underscore values. You see, no auto completion. Spelling is capitalization is very, very important. If you make a mistake and call these values like this, you'll get a very spiritual error and you'll never know what the actual issue is because C++ is very brutal. It doesn't tell you what the error is. It just tells you something went wrong. I don't know what it is, but you did something you're not supposed to do. I don't know what it is. Figure it out. So that's C++. Be very careful. So now, since we're used to new int, remember we are used to int, double int pointer, or let's say RGB color pointer, then you allocate. If it's one dimensional, then you remove that first pointer, you replace it with square brackets, then provide the size. It's still the same thing. The only difference is that now our array is now of type T, meaning any type. So therefore, I'm gonna come, okay, the thing is if I use any type, that's a very long term. But for the sake of you guys to understand, I'll name this, I'll change it, remove it from a T to any type. So that you literally know that it means any type. It takes in any type. And then this get value function returns any type. This array is going to be an array of any type. That's why I said it's better. I think it's better for me to name it this way so that you guys don't get confused. And then that means everywhere where there's a T, I must replace it with any type because I've renamed my template to not be called T, to be called any type. And then so now remember it's the array at every single index. What's the data type? It's any type. So I'm gonna come here and say any type pointer because it's the data. This array is of type any type pointer. Remember how to allocate. You replace the pointer with the actual square brackets to define what the size for that dimension should be. So the size for this dimension should be underscore length. So you can use anyone. You can use the length as the parameter that's being passed or the underscore length. Why? Because in the previous line, we did set them to be the same value. So that's up to you what length you use. So now if you remember, our arrays, we always give them default values. I always say 4, and then I'll use unsigned short, I is equals to 0. And then this thing is very tricky, man. You have to be very, very careful. And then I is less than underscore length, because that's the size of my array. And then for the sake of you guys not to get confused, I won't put one line. I won't omit the curly braces. I'm gonna put them. But I just know when you have with the for loop, when you have one line, you can omit or remove the curly braces. So now I need to initialize my values array at every single index I. Remember, I don't need to add deallocate again because this is not a 2D. There's no missing pointer that needs to be allocated. I've already allocated all the pointers that are there because there's one pointer, meaning there's one dimension. So I can just work with my array now. I'm done allocating. Then I'm going to say is equals to what's the default value now? You see why we couldn't do this? Let me do it so that you see the problem. So this is static const int default value is equals to 100, right? Default value is equals to 100. So if I come here and I do this spiritual thing and I say default underscore value, this will only work provided you pass in an integer. But remember, our array is of type any type, meaning that the int can be a boolean. So in essence, what you're trying to say is you're trying to say a boolean set it to an integer. But this boolean, right, should take in an integer value. What if sometimes I put it, I use char to create this class? That means you're trying to say this character should take an integer type. Or what if it's a string? That means it should take in a string, an integer. This string should take in an integer, of which you saw inside main.cpp that when you define this function and it only prints a string and you pass a number to print it, it crashes. So in order for us to avoid this thing of assuming that it's going to be an integer, because what's the point of making a class take any type only for you to enforce users to only pass in numbers? It goes against the whole purpose of you creating the system or the project. So therefore, you're not going to need a constant for default value. You can have a constant for default rows or default columns. You can have that. So that's why I passed a default value here, because I don't know what data type the user is going to use, because this class can take any type. So when it takes any type, whatever that type it is taken, use that to set as this default value. That means if I've set this class to work with booleans, that means on the right hand side it's going to be initialized to a boolean. If I use this class and it should only work with characters, that means the default value here will be a character. So that means I'll be initializing a character to a character. And then if it's a string, I'll be initializing a string to a string, so that I avoid any errors. It won't crash. So you see that's another reason why we can't have a default constructor, because remember, default constructor, you need to initialize the array to a default value, but what default value? Because this class can take any type. So what do you mean? Remember, you can't do this. You might be like, yeah, but I can create a variable of any type. Yes, you can. It's a variable that takes any type, but what is the default value for every type? You see, you start getting problems. You can't use 0. What if it's a string? What if it's a char? What if it's even a UJ image? You get what I'm saying? Like, you can't 0 and UJ image are two different types. UJ image is an object. Int is a data type. It's a primitive data type. So you see that you get confused. The moment you get confused, just know that you're on the wrong track. If you're trying to create a constant and you don't know what value to give it, just know it's impossible. Hence, we create a constructor that takes in that default value that the user should initialize. So the user should give us that default value so that the program doesn't crash, because we don't know. Our class can accommodate any type. I hope that makes sense. I hope that answered your question.
Yes, it did. Thank you.
Okay. So now we need to get the value. So I need to pass in the index or the row or the column, whatever you want to call it. Let me call it the row. Let's say that this is an array of rows, whatever you want to call it. So the length variable, actually, you can call it row underscore rows, whatever you want to call it. So it gets that value, that it returns. So return. Remember, it returns any type. So any type, it could be int, it could be a char, it could be a boolean. It's any type. So hence I need to put the keyword any type there to tell C++ that this is any type. And then return underscore values. But then remember, this is a whole array and I want to get back one value. So I need to pass in an index. Hence I taken an index. So what position? It's at position row, whatever is going to be stored inside this row variable. And then I return. Before returning, you can also check the size if it's valid. Enforce range, you can do that. But remember, for the sake of time, I don't wanna implement the whole class. Yeah, so I'm going to what is this now? Deallocate. So you can use a set to make sure that it's not equals to null, but I'm not gonna do that. I'll just delete, right? Remember, it's one dimensional. So I only need this to delete one dimension. So delete that one dimension, I'm done. But then I need to cut that cord or that connection so that the user doesn't mistakenly point to a location that's non-existent. And if they do, they get a clear error that states that they've pointed to a non-existent location. So it's equals to null pointer. So when this is set to null pointer, at least we'll be able to get an error called segmentation fault, of which that segmentation fault error helps us know that we've tried to point us to a non-existent location, which is what we want. And then remember, don't forget to include your implementation here. So do not forget to include your implementation file after making the class, declaring the class. So we are done basically making use of a template. Any new thing that you add, you must remember, look, this is the syntax. You say array, the name of the class, and then you put in the less than sign, and then you pass in whatever you've named it here, whether T or type or X or Y, whatever the thing you've used, you must also put it here. And then close with the greater sign. And then put the scope resolution operator right next to the name of the function, or right next to the destructor, or right next to the constructor. So we have deallocated, everything is fine. Now we're going to use the class. So let's make use of the class to show you that this class is easy to use. And remember what I said, same way we've used the function here is the same way we're gonna use the array class. But then remember, in order to use the array class, I need to import it. So hash include array array.h, and then here I'm going to, what is this? Create an instance. Create instances. I'm going to show you how flexible this thing. Instances of different types. And I also need to go through, I want to print the whole array, right? So I can do one of two ways. I can call the print array function. I can define like a 2p, sort of like a 2 ppm function, or I can return the length of the array, then use that length, call that length in the main.cpp to go through every single value in my array, then display it. But then I want to make things simple. I'll just create a void function right? Which is meant to display. I just call it display. And its only task is to display. So I'm gonna put a const at the end to say that this should make sure that the code that it defines within this function does not leaves the object in constant form, basically the way it found it. And then remember, every time you define something, you need to add that template. Why we need to add that template? Because you need to, this is how you specify that you are going to this templated class. You need to always provide that type there. So we need to provide this type here. So hence we need to always put that template on top of every single method and function, method and constructor and destructor. Even operators, anything that's part of the class that's regarded as a function. So here I want to display, right? Simple, I just want to display. There's nothing fancy here. So I'm just going to say for unsigned short I is equals to 0. I is less than underscore length. Make sure you spell very well. You pay attention to details, because if you don't, it's gonna crash and it won't help you, because .imp is not a C++ file. Hence, it's not gonna provide you auto completion. So I'm going to say cout here, but then in order for me to use cout, I need to say hash include using standard namespace here. Or you can put it in your header file, array.h. It's up to you. I would define it here and say IO stream. You see, no auto completion. You need to be very good at programming here. It's very annoying, this thing. So I won't say using standard namespace. I won't do that. I'll just say I'll specify that it's from the standard namespace. Cout, what am I outputting? It's my array, my values array. So values at index I. And then after every single value that I output, I put a space like this. That's just for me, that's just important. And then so it's important because so that it's readable. Why that space? This means that if the first value is 10, 12, and the next value is 32, if I leave it like that, you see, you think it's 1232, but it's not. It's 12 and 32. So therefore I need to append the space every time after I've displayed the value. So you see now it's readable. It's 12, 32. And you could also output a text and say array values like this, and then display, and then like this in this format. You could do that. So you could do that, but I'm not gonna do that. Okay, I'll do it inside main. So I'm going to output an end of line character after I've displayed every single product, every single value of my array. Yeah, I'm saying product because I'm thinking about informatics to be. So we have this functions that we implemented. Now underneath here, we're gonna call our class. So create an instance of the class. So array. So now array is what was that term? It's generic. So that means it can take any type. So therefore, every time you create an instance of array, you need to pass the data type of the array. So here I'm gonna put brackets like this, the greater than and less than symbol. And then within those two symbols, I pass the data type of the array that I want it to be. So the first array, I want it to be an array of integers. And then I'll give it a name. It's going to be array, and then I'll give it a name. I'll call it obj integers. And then remember, there's only one constructor, which is the parameterized one. So I need to pass in two values. And you see it's picking it up. He sees, okay, this is the array. And you see what's highlighted in blue. That means that's the current piece of data that I need to pass, which is the size or the length. So I wanted to have size 5, right? And then what's the value? What's the default value? And remember, it's of any type. It will look at what type you've passed here and then compare it with the value that you're passing here. Because this type you're passing here, it means that that's the type, that's the value for each value in the array. So therefore, if each value in the array is given a default value, this type over here needs to match the type that you're passing here. So I'm going to say initialize all of my value arrays, all of my values in the array to 0. And then, oh, so I actually don't need the get value method because I've implemented the display, but that's fine. I'll just leave it. So now I'm gonna display my array, but before I display my array, I need to say cout and say integer array so that we can see the difference. So immediately after I put in the string, I want these values to be on the same line. Hence, I'm not putting an end of line character. And then after this, I display my array values. So obj integers dot get or display. And remember, I don't need to append an end of line character. Why? Because when the display function is called, it automatically appends 1. That's you could put it if you want, but I don't see the need. And you see, I've declared an array of integers, right? So far we should see zeros. Let's try to build. Yeah, I knew that I was face an error. I'm so used to underscore pixels. It's underscore values, not pixels. Underscore values. My bad. I'm so accustomed to pixels. And then build, and then there's the object obj integers dot display. Oh no, what am I doing? Yeah, I'm so used to images. I'm thinking of the to ppm. Remember, this is a void function. It doesn't return anything, so I don't need to call cout. It's not to ppm function. So you just call it and then implement. And then build and run. You should see that it's gonna display zeros. Yeah, you see? Zeros. And don't be like, yeah, it's so nice being you. Your code always runs in the and you can fix your errors quickly. Yeah, it's through experience. Since there's also times that I got errors I didn't know how to fix them. It's through experience. So I'm going to create another array, but then another array instance, right? So this is array of characters. So the thing that changes here is I pass in a char there. But then the type needs to match. I shouldn't pass an integer because it's now of type char, the array. That means the default value for the array, each value should be a char or a character. So I'm gonna pass here and say A. Let's say A, right? Let's say A plus. Let's say you got A plus in all of your tests. So I'm gonna say obj chars. That's what I'm gonna name it. And then put there and then call it character array. And you see that for some weird reason it now displays characters. And I didn't create a class with an array of characters. But you see, it's for some weird reason it's displaying. Okay, my bad. I see why it's displaying A because these are two characters. Char, you can take in one character. So it's either you put the plus or the A. Choose one. It's not a string. So I'm just gonna pass A. So we should see A's now. So you see, it's the same class, but it's displaying it's working with two different arrays. That's the beauty of templates. You don't have to create a class that handles integer arrays, an integer array, and then you don't also have to create another class which handles a character array and another class that handles a string array. You don't have to do that. That's the beauty of templates. And then I'm just going to define two more arrays to just sort of like confirm to make sure you really see that this thing is unique. You can use any types. So string, and then this should take in a string, and I'm going to call it hello. And then this is going to be my string array or strings array, whatever you want to call it. And then this is an array of booleans, right? Let me use a boolean here and then just set it to true. But for boolean, remember, it will show 0, 1. We don't want that. So what I need to do is, okay, I need to rename my arrays because they're of the same name. It's gonna crash if you declare variables of the same name because we can't have boxes that are labeled the same. You get confused. What if the box has poison and you thought it had something else, and then you started eating that thing. So you get what I'm saying? So you shouldn't use the same name. So I'm gonna say obj strings because why? It's an array of strings. And then put that there. Call the display method on the obj strings because that's my object for my strings. And then this one will be obj booleans. I'll just write it, call it obj booleans, and then dot display. And then if I build and run, you see that all of the arrays are displayed. All of them is the same. It's the same class. But look at how many data types I've used. They're all different. So for Boolean, remember what I said in our previous session. For Boolean, by default, it either outputs a 1 when it's true or a 0 when it's false. So you need to change it to be in alphabetical manner, right? How do you do that? You use the std, use the bool alpha method, which just means from bool to alpha. By alpha, it means alphabet, meaning text. So how do you do that? Just simply say cout bool alpha. And then now it's gonna output the 1 in text form. Basically, what does the 1 mean? It means true. What does the 0 mean? It means false. So there it is. So this is how you work with templates, and you need to be very, very careful how you use templates, because if you mess up the order and everything, like for example, let's say I do this, right? Let me cut it here. Let me show you. And then I include it before it actually, I included it before the class actually came into existence. So that means you won't know what array is. So they should fail. Exactly. It should have a type not defined or something like that. Exactly. Array does not name a type because you're already pasting this thing before you even define the class. So basically the class does not exist. So it's going to ask you, what do you mean by array? There's no such thing called array. C++ is like that. Even not every programming language is like that. It reads from top to bottom. So make sure you include it at the bottom. So const. So make sure you include it at the bottom. Do you guys have any questions?
I don't have.
Okay, Kuketsu, do you have any questions? Okay, seems like he's okay. I'm not getting a response. So I'm gonna assume you're okay. So this is pretty much how you do templates. So let me check the file. Create a main function which demonstrates the functionality of point cloud 2D generic class. So did they give you extra because I don't know where they're getting point 2D class. Did they give you additional files for this practical?
No, they didn't.
Also, I'm assuming they want you to create it, but I don't see where they say you should create it. And C++ afraid to chows. Even for me, who's experienced, this thing shouldn't be taken lightly. Because now you're gonna overload the double indexing again, but this time around, the raw class needs to be generic, which means it needs to also make use of templates. Hey, people's codes are gonna crash. Yeah, I can see it coming. This class on its own is gonna cause problems. This one, it's small, but it's gonna cause problems. But just know that every time when you defining something or implementing something in your class, it must be accompanied by a template on top of it. Because remember, since that array class is now of a template type, every time you make use of something within that class or you declare that class, it's actually this way now. we start with the name of the class and the data type of that class, that the data type that class uses. So yeah, that's pretty much templates. The thing is, I don't know how long, okay, but it's around an hour, so it's not too long. So if you guys don't have any questions, I think I can end the session here. Let me see if what about questions on the practical? What specific section do you want me to explain that you're not understanding? Are you guys still there?
The fifth bullet.
Um,
One.
this one.
No, not that one. Number 5. The black
Uh,
one, number 5.
1, 2, huh? 1, 2, 3,
1,
4,
2,
5.
3, 4, 5.
This one.
Mhm.
Oh yeah, this one. What they want you to do, right? I can let me just overload the operator now. So overload the invocation operator, right? I think that's what it's called because you're invoking a value from your array. Okay, let me drink water. I'm parched. Okay, so this operator, right, to overload it, it's pretty simple. It's like an accessor. Remember, when you access something, if it's a two-dimensional array, your class is a two-dimensional array, then you have to pass in two values, a row and a column. If it's one-dimensional, you only pass a row or a column depending on the approach. So obj1, what did they say? We'll swap the values in the array randomly, right? The parameter to the operator function should be the desired. Wait, let me see. Or the parameter to the operator function. So the parameter that you pass to this function should be the desired seed value for the number generation. So for example, obj1, and then you pass it the seed value. So the thing is, I don't know random arrays. What is randomizing in such a deep manner that I can explain it in a deep manner. I really don't know what the seed value actually does, but like what it like really is. But with the seed value, you use the seed value when you want to generate random values. Because with the random function, right? So remember with randomization, you need to make use of the ctime library, right? Because you want that srand and time method. Let me see. Am I missing C standard lib? Let me just double check. Am I missing C standard lib? Is that where the srand function is? Or is just not auto-completing? I guess it's just not auto-completing. So what you can do is you can seed the number generation, right? Meaning that pass in a value into the randomization. I hope srand is correct. I haven't used this thing in a while. So srand function, it's basically like in full, it's like seed the randomization or the randomization of values. So srand or seed random, whatever you want to call it. And then you can pass in the time function, which takes in the time or the seed value. So here you actually take in the seed value. That's what you take in there. So usually they pass in the value 0. Or you can pass in any integer. So this integer just helps us to make sure that every time the program is run, it generates a different random value. So how do you generate the random value? It's quite a tricky thing, right? So let me explain the formula. So with randomization, this is how randomization works. With randomization, let's say we have values. Let's say I want to generate a random value between 1 and 5, right? How can I find the range? Basically, how can I find the range, or basically how can I find how many values can be generated? So if you look at here, this is simple math. 1, 2, 3, 4, 5. That means there's 5 values that can be generated. And we call that the range. If you know your maths very well, you know what that means. So that's the range. It's 1 to 5 or 5 values, meaning the range. How can we find, what's the formula to find that range? It's simple. You take your upper bound minus your lower bound, right? Meaning your where the range ends and where the range starts. And remember, for this one, this is inclusive, right? Square brackets. Going back to maths, me, I don't like maths. Me, I like coding. There's maths in coding, so you can't run away from maths. No matter where you go. Me, I like AI. I like way the stats and physics and maths. The worse, so you can't run away from maths. It's a very important thing in our life. So upper bound up to minus lower bound. So in this range here, what is the upper bound? It's 5. Basically means that this range stops at 5. Where does this range start from? From 1. So which is you see that this is a problem. It won't match. So here I said these are 5 values that we can be generated, right? But if you look at the range, the formula for calculating my range here, the answer is 4. 4 doesn't match with 5. So we have a problem. So how do we fix that? So the formula is actually not complete. To fix that, okay, let me show you what number should I add to go to get 5, which is the actual number of values.
1.
1, right? But what is 1? 1 is actually the lower bound. So the formula in full, it's upper bound minus lower bound plus lower bound. That's how it works. So this will just be plus 1, which now gives you 5 numbers. And you can test it out with any values. Even you start from 2 to 4, 1 to 10, test it out. This formula holds true because mathematicians are involved in coming up with these formulas. And you know how mathematicians are. They have to be accurate. They like being accurate. So I'm going to use this technique, right? So since this randomization will be done within the function or within my class, I'm gonna do it there. And if you check something, right? Remember what they said here. Overload the stream okay, not this one. Where is it? So the parameter of the function should be the desired seed value, right? What's the seed value? If you looked at that srand function here, the value that must be entered in place of 0, that's what we call the seed value. So I'm gonna delete that and then go back for the number generation. So for example, this is how you can use that operator. And you see that you see that it doesn't return anything, right? Do you see that? They didn't say obj1 1337 is equals to. They didn't say obj1 1337 is equals to, for example, 10. So it doesn't return anything, or it doesn't return anything, so it's a void. I picked that quickly because I looked at how it was used, the example. That's why they give you examples. They don't just give you examples because they are bored. They give you examples so that you know how you should implement, so that when the memo comes back, your solution matches the memo. So I know it's going to be void, and then I'm going to overload that operator invocation. And they said it takes in a seed value. I know the seed value, it can be negative, right? Remember, it can be negative. So what I'm going to do is I'm going to make it a short since it can be negative. This is basically a signed short, meaning it accommodates both negative and positive. And remember, short, it goes from ranges 32 minus 32,000 to positive 32,000, which is, there's no way I'm going to pass a very big seed value. So that's why I'm using a short. And then I need to implement this side. No, what am I doing? Ish, the syntax, I'm messing it up. So I want to overload this operator, and then I'm gonna pass in what parameters? Short. This is the actual syntax. You're overloading this operator here. And then what parameters are you passing in? It's only one short. And then I'm gonna go this side, and then I'm gonna go here. And then remember, always put on top of everything that you're defining that template type name T. And then copy this, put it next to the function. And then they said we need to seed, right? So it takes in a seed value. So this short is actually called a seed value. It's a value that you use to seed our random function. So I'm going to say seed our randomize or random function, right? So the formula that I was talking about, so if I go back to main.cpp, if you go back to this formula, how do you find the range? So to find the range, you call this random function, right? To find a random value, I mean, you call this rand or random function, and then apply the modulus operator, you provide the range of values. So basically, you divide by the range of values, meaning that you want to randomize and get a random value between this range of values. But if I forget the upper bound, that means I'll have less values than the actual range. So therefore, I need to always add my lower bound. I hope that makes sense. You take a random function, you use the modulus to pass the range, which is just this value here. Remember that you could just do this, right? Our range, the way we're gonna view our range, right? It's this upper bound minus lower bound, excluding the lower bound. Hence, I end up adding into the end here. Or you could just write it in one line as it is, and then here you just say modded by or modulus range. You could do that. There's two ways. So it's up to you how you want to do it. So I'm just gonna do it this way. Just do it in one go. Store my range and then mod. Done. That's the formula on how you generate a random value. So I know it's going to be okay, so let's see. Okay, before I go to this, let me go to my implementation. Okay, let me zoom in. So that's my let me see the random function, right? So srand, but before I call srand, I need to use ctime. I need the ctime library. So ctime library. And I know you guys don't like it, but I'm just gonna do it this way. I want you to say using standard namespace. Srand, and then it takes in the time function, which is inside the standard library, and then I pass in the seed value. I know it looks weird, this syntax, but trust me, in the industry, that's how they actually use C++. You always need to specify which namespace are you taking that thing from. So I've seeded my random function. So now the formula, after seeding the random function, we need to find a range, right? Remember, in order to generate a random value, we need to find a range. So this one, it says that using the seed value, the operator function would then do the following. At each location in the array, generate another random location. So then remember what do we call a random location? It's at row R and rows in column C. That's what we call a location. If you remember in your Cartesian plane, when you say this row, that column, we get that point or that code. We call that the coordinate, which is like the location of that value in our Cartesian plane, right? The same applies with the 2D array, even with the 1D array. But in my case, I have 1D array, so I only need to find one of them, a random row or a random column. In your case, you need to generate both a random row and a random column, which is really a lot of thinking involved, but at the end of the day, it's not too bad. So, and I need to do this every time, right? Let me show you. Let me explain. Let's see. So, but after generating the random location, you use that random location in your array and swap the current value or the value stored in the current location and that other location. So for example, I'm currently at ij, and then I generated a random value and I stored it inside the variables r and c. So r is going to store a random row and c will store a random column. So let's say that's what I've generated. That means the values at rows r and c should be transferred into values of I and j. We swap them. And before you do that, you need to understand how to swap. Let me show you the formula for swapping. It's very simple, but it's also very simple to fail. So let's say I have int a is equals to 10, and I have int b is equals to 12, and I want to swap. And then at the end of swapping, I'm gonna say value, output the values of each. So value of a is a, right? And then end line, and then see out a value of b is b end line. Come on. End line, right? So before I do that, I need to, so I can do this, right? I can output the values twice. The first time it will show the original values, and then the second time will show after the values have been swapped. So I can also just do this after swapping values. I can just do that, right? But then I need to actually swap the values. Some people might think this is the easiest thing to do. It's not easy if you can't think. So let me show you why. Remember, every time you use a variable, you are telling the computer to go to that box with that label or that variable's name and change that box and put this new value. You see that it's changing the new value, but in the process of changing this new value, we are not keeping track of the old value. That's where the problem comes. So I'm going to say A is equals to B, right? Swap A and B. Basically, take the value of B into A, and then I take the value of A into B, right? It seems straightforward, but you see something that's going to be wrong. So what this first of line of code does, right? It means that go into this box with this label A. It's called A, that box. Take the value of B, which is 10, which is 12. So A will now be 12. A is now 12 because it takes the value of B and B is 12. So A is now 12. And then I tell the computer change the value of B to the value of A, but A is 12. So it's going to be 12, 12 because A is 12 and I found B being 12. And then I set it to a new value of A, which is 12. So this means both of these lines will store 12, which is wrong. Shouldn't it be 12 and 10 when you swap them? Yes, it should. But then look at what happens when you don't really understand your logic. You see, before it was 10 and 12. But then you see it's 12 and 12 because we are not maintaining or storing the value of the old the old value before putting the new value. So how do we do that? It's simple. I created a variable and call it temporary, meaning that it's a temporary value, and it stores the value of A before I change A, right? And then I change A, so A is now 12. So I can't use A here because has a new value. I must use its old value, or I can just call it old value. So I must use A's old value because now A has been updated. and then use that old value to set it to B. So now it becomes 10, 12, and 10 as expected. So it's a simple trick. It's a simple thing. You might be like, yeah, I'm understand. I'm gonna kill it, just simple swapping. But it's not really that simple if you don't understand your logic. So you see, B was 12, and then A is now 12. A was 10. No, what am I saying? A was 10, and A is now 12. B was 12, now B is 10. We've successfully swapped the values. So that's the formula. You always keep track of the old value. So before you do that, let me do this. So they said we should go to a random location, right? And then swap in that random location with the current value, right? So I don't know if you should continuously do this or what. Basically, should it be within the for loop? So at each location in the array, generate, yeah, they said at each location in the array. This is where they gave you the hint. That means your random generation code should be within the for loop because they said at each location. So unsigned short is equals to 0. And then I is less than length, and then I plus plus. And then within, they said at each index, right? So remember, I have a one-dimensional array. So it's for me, it's a bit simpler. So what I can do is I can say, and there's a trick that's very useful that you can use. So remember, for loop, this part, the first part is called initialization, right? It executes once the first time the for loop runs. So, and remember to declare multiple variables of the same type, you can use a comma and separate them with a comma. So I can, if this is 100% legal, I can come and say comma, and then that value that I'm going to use to store the random row or the random column, I'll call it random call, right? And then initialize it to 0. I know it's the syntax that you haven't thought about. You haven't thought about the array in this deep sense, but this is the for loop I mean. But this is possible. Remember, the rule for declaring variables is that if they're of the same type, you can declare them following each other, but then separated with a comma. So I'm still abiding by the rules. So that's fine. So I'm going to declare it there and say I'm random call. Remember, this is a .imp, so it's not going to provide autocompletion. So random column, how do we generate? Remember the formula I talked about. We need to say rand function, which is inside the standard library because I didn't use, you know me and my ways, I didn't use, say using standard namespace. So since it's within the standard namespace and it's called rand, I need a range, right? So I need to generate and the range needs to always be a positive number, right? But sometimes you can have negative numbers. That's fine, but I think it should always be a positive number. So since I'm going to go with that assumption, that's always a positive number. I'm going to create a variable called range, and then I said it says equals to, what's the range? Remember, the range is always upper minus lower. So what is the upper here? The upper is basically, let me cancel here. So look into the array, generate the random location, and then swap the values in the current location. So remember, what am I generating here? A random column. So that means the range, my upper range is actually the number of columns. That's my upper range, the number of columns, which is underscore length, minus my lower. So the lowest value that it can be, which is 0. That's the lowest range it can be. It can go from, okay, but it's excluding length, right? I know it's weird, right? I know the syntax is weird, but it's logically that's how it works. Remember the column is within this range. Let's say you have 5 columns. That means the range is between 0 and 4. So what's the actual formula for finding the range? It's 4, which is the upper bound, minus 0, which is lower bound, plus 0, which is the lower bound. So how do I get this 4 if it's already stored in a variable? That means length must be subtracted by 1 before I subtract 0. Because remember, length stores the actual integer. So if you have 5, it stores 5. So I need to subtract 1 here and then put brackets. And then after subtracting 1, this will give me, for example, 4. And then 4 minus 0 is just 4. And then plus 0 is just 4, which is fine. The formula works, right? You might think, yeah, why don't you just write 4? I want to be very accurate, so I'm going to leave it like this. So, and then I'm going to mod by my range. So now I found the random column. There it is. Then I need to swap the two values. Remember, to swap, we need the temp variable. So that means I need to swap value at location or at column random call with the value at column I. Remember, I'm in a for loop and the variable is I. I'm going through all the columns, assuming that this array stores represents it's an array of columns. So I hope we're still on the same page. So I need to swap them. But in order to swap them, I need to create a temporary variable. But hey, these people are in a comsci child if they don't understand. But the array, the values arrays of type any type. That means that at every index I get any type. Remember the formula, it was this int. So let me change this to C++ so that it highlights. So int, it was temp or old value, right? Old value is equals to a. That was the formula, right? And then you said int a is equals to b. Okay, let's assume they're already declared. A is equals to b, and then b is equals to old value. Because if I set b to be the value of a, I'm just in essence setting b to b, which is just gonna be the value itself, which is wrong. So I need to get the old value of a and set it to b. So that's the formula. So I'm gonna go back here, and then I'm gonna get the value, right? So I need to use any type. I need to create a variable of any type, and I call it value, right? And then it's gonna store the old value of a, right? In this case, a can be the value at random call or random I or at I. It's up to you. So this will be at values random call, right? So now I've stored the old value at random call. I can now change it safely because I'm keeping track of the old value. So this will be old value. And then I'm going to now change the value. So values random call is equals to underscore values at I, right? And then underscore values at I is now equals to the underscore values at random column, but it's all the value. If I try to set it to this, I'm basically setting values underscore values I to value underscore values I, which is basically setting it to itself, which is wrong. So I need the old value of random call. And then there's the old value. And then we've swapped successfully. And I need to repeat this within the while loop over and over. The only difference is that you're gonna have ij. That's the only difference, pretty much the same thing. And then that's pretty much how it's gonna run. Let me try to build and see, because I'm not using namespace standard. I'm expecting errors. Wow, I'm becoming good, Mos. Running it the first time, no error. Eh, So what I'm going to do, right? I'm going to randomize values How do I randomize? By using that operator. So since I'm randomizing values, I'm going to, let me think. Okay, let me use the characters array because characters we can see. So let me create a function that to set the value, a setter. So void set value. So I need to take in two things. At what index are you setting this value? So answer in short, and what is the value, which is of any type, because my array is of type any type. And then I copy, and I shouldn't append a const at the end because it actually is going to change my array. So therefore, I shouldn't say const. If I put const, that means I don't want it to change my values, which is wrong. I want it to change my array because it's called a mutator for a reason, because it mutates or it changes. And then here, since I want to access these parameters, I'm gonna get call it column because that's gonna be the column, and then the value gonna be that value. And then I'm going to say underscore values array at that index or that column is equals to the second parameter, which is the value that we are setting it to. Why am I doing this? Is because I want to set the different value characters into my obj chars so that it has different letters A, B, C, D, G, whatever. So that when we randomize, we actually do see the randomization. We see that the order is changed. Or you can use integers, doesn't matter. So let me change my obj chars dot set value at what index. So I know it is 5 numbers, right? I'm gonna leave the one at index 0 to be A. So this is my order. At index 0 is going to be, I want to leave it as A, so I won't change that one. At index 1 it should be B. And then at index 2 it should be C. And then at index 3 it should be D. And then at index 4 it should be E. So that's how I'm going to change my values. So you see that I don't need to pass index 0 because I want it to remain as it is. So I'm going to pass index 1 going upwards. So set it to B at index 1. And then I need to repeat these lines for 4 more times. 1, 2, 3, 4. Okay, 3 more times. At index 2, set it to C. Right? And then at index 3, set it to D. And then this is in E at index 4. So now I know my obj chars is different value, unique values. So let's try to randomize it. So let's randomize what obj chars. And remember how you randomize. Use the invocation operator, which is that invocation operator. And then you pass in one value. Why one value? Because if you look at how it's supposed to be used, it takes in one shot, which can be any negative to a positive value, from negative 32,000 to positive 32,000. So let's say our seed value is the one that they've specified as an example. Let's use that one. So 1337. So here I'm randomizing my values for obj chars. After I've randomized, display the new order. So obj chars dot display. Remember, display function it returns void, so I just call it like that. Let's try to build. Okay, I knew that it was going to complain at some point. So I think I'm forgetting a library. But why would it complain if I'm converting it? Okay, seems like it doesn't like the data type that I've used. Let's make it an int then. So this should be an int. It still might not work because it's actually expecting a long int. We inganekwane. So it's expecting a long int. So use a long int. That's what it's expecting you to pass. Long int. Or you can just say long. Let's see now. Okay, still, so that's not the actual problem. Let me change it back then. I thought it was because it says it's not that type that it expected. Okay, I don't. But then we always use the time function. If I'm not mistaken, we always use the time function. Let me try to pass without the time function. Oh, yeah. So just avoid the time function. It seems like the time function doesn't want to work. So just only see it with a specific integer, right? That specific integer. Now I'm cruising nice now. So I'm like almost at Prof. Kuta's level, getting there slowly but surely. Because I just fix in errors fast, and then done, move on to the next one, and then it compiles. That's why he's the GOAT. So let me build and run. So there we go. It does work. Perfect. So you see what I was talking about. It does work, but I need to let's output the actual order before after setting it. Let's display after setting it so that we get its original state, so that you can see that the order did change. So this is actually how they want you to do it. It's not actually, you see that it's not bad. It's not really bad. So you see, this is the order. It was A, B, C, D, E, right? And then now it's A, E, D, B, C. It was randomized every time. So you see now the values are in random order. Even though the first letter A is still it's random. You might think A hasn't changed. It's random. You choose a different seed value, the randomization will be different. That's pretty much how it works. Do you guys have any other questions?
I don't know.
Yeah, so this is exactly how you should declare it in your practical. Just set it to that. Basically, this is exactly the same thing with your practical. The only difference is your practical, right? The only difference, which is really nice. The only difference is this all of this code here should be within the second folio for your columns. How are you're gonna have for int r is equals to rows less than rows, blah blah. For int c less than calls. Then within the for int c1 for the columns one, you put all of this code within it. And then now you're double indexing RC row and columns because you have a 2D array. Me here, I had a 1D array. So for me it was straightforward. I put it within one loop. I hope you guys understand. Let me see how long is it's almost 2 hours. Okay, one and if you around 1 hour 40 something minutes because I spent 20 minutes just trying to set up some things. So yeah, if you guys don't have any questions, then that's it for today. If you end up having any questions, just let me know because you never know. You might have a question and other students in your also have the same questions, right? Then we can have a session. I implement that section that you're confused by, show you an example of how it should be done or how it should be approached. So thank you for attending. See you in the next session. I'm going to upload the recording and then I'm going to share it in the group. So let me stop recording. Yeah, I am tired now.